enjoyed some of the ideas that came from the formula that works with this difference of two perfect squares, right? A squared minus b squared, that factors with the difference multiplied by the sum, or some people like to say it's a sum multiplied by the difference, because multiplication commutes. So we can put any of these factors on the first place. We'll also notice that if you have a sum of those so-called perfect squares, then it's a non-factorable expression, and we say it's prime. Prime means we cannot factor this. So we looked at various cases where we practiced on factoring with differences of those perfect squares. So let me do one exercise. Let's say exercise in the problem number 31 here that uses formula above that says if you try to factor a difference of two perfect squares, and we actually do have a difference of two perfect squares here, because my first will be x squared and the second factor will be y squared. And then they're also squared. So I could write this as a x squared minus y squared multiplied by x squared plus y squared. So this way we can factor 4's powers by turning them into the squares, right? And then what I can do is keep working on my first parentheses. I can write this as x minus y times x plus y without squares. And don't forget about the second factor, about the second parentheses with this x squared plus y squared, which is non-factorable, or in other words, it's prime. So it looks like this is what we have for our formula use. And whenever we have those so-called perfect squares, you can always do the factoring. So this will be used from now and on quite often. So I'd like to move to the next section and see the other kinds of factorings that they provide us with in here. And for example, they show how to factor so-called trinomial, which is polynomial with 3 terms. And the way we factor is we look at the first term of it and the last term. And when you factor first term, a squared, you have 2 factors, which is 8 times 8. And then the last term, which is negative 12, that you factor with a 3 and minus 4. And turns out this way we're done, because you can always check and see that indeed the factoring works by multiplying what's inside by and what's on the outside. So you're gonna end up having 3a when you multiply 3 by a on the inside. And then on the outside, I guess I want to clean this, just too messy. So inside will be a product of this 3 and a, so it's going to be 3 times a. And the outside product will be negative 4 multiplied by a, so it's minus 4a. So the middle term, negative 8, is exactly a difference of 4 minus 3, so it's negative 1a is what we get. So the idea of factoring first and last term is here throughout the entire section. And that's very popular type of factoring that you will see a lot. So looks like we're gonna have this x squared and 12 factored with 3 and 4. So you can imagine myself factors of the first term x squared, which is x multiplied by x, and then factors of 12 will be positive 3 multiplied by positive 4, just like that. And of course, we should always make sure we did it right, to double check, to actually multiply the inside and the outside pair. So we get a 4x when you multiply 4 with x, and then inside it's 3x. So when you put these together, you will get 7x in the middle. So that's the plan for all of the exercises in here. So I can actually go to the practice part at the end of the section as usual, and we can practice factoring those various little exercises. So 25 here with x squared and 9x plus 8 is what I'm gonna write as a product of 2 parentheses. So always the first step is to put 2 parentheses, and then we factor in the first term x squared with x and x, and then 8 you can factor with 8 and 1, simply because the sum of 8 and 1 is equal to 9, and that's what we need, because the middle product is 8x, and the product of terms on the outside is 1x, so this is 9x is the answer. So it turns out when everything is positive, like in the exercise number 25, in the parentheses you encounter pluses. In exercise 31, not everything is positive, so you see that we have x to the second power minus x and minus 30 that I want to break as a multiplication of 2 parentheses, and factors of first term x squared is going to be always x and x, but now I need to think of factors of negative 30. So one should be negative, and if I put negative 6 multiplied by positive 5, looks like this is going to be exactly what we need in here, right? Because inside product is negative 6x, and the product on the outside is 5x. So minus 6 and 5 is exactly the middle term, negative x. So in this case, we subtracted 6 and 5 because their signs were not the same, they were different signs. I think the nice example is 33 here, because you don't have many choices in factoring of expressions of this type. This is x squared added with 2x and added with number 1. So when you prepare the pair of parentheses and you factor x squared with x and x, then going to factor positive 1, you have no choice but to break it as a product of positive 1 times another positive 1, right? There is no other possibility here to factor 1. And when you check this out, you see that indeed the products on the inside and the outside are both equal to x, and their sum is 2x. And that's exactly what I have to factor originally. please notice that they wrote this a little bit differently because they noticed that x plus 1 appears 2 times in the product. So instead of multiplying x plus 1 with another x plus 1, they just wrote it as x plus 1 raised to the power of 2. So this is a possibility, and that's good to realize that you can write it also in that format. So factoring is our practice here. So let me try to factor one more, exercise number 30. So in this exercise, again, we have ourselves a good start. X squared in the beginning is always nice to have. So I'm going to prepare the 2 parentheses so I can start factoring. And I'm going to put x's on the first positions in both parentheses. Now, it looks like I have a negative 12 here, right? So I need to put a minus. And then there is another minus because my goal now is to factor the last term, that negative 35. To get positive 35, I have to have 2 minuses. So the product is plus. And looks like in timetable is 5 times 7 or 7 times 5, right? And notice that the inside we get a minus 5x. And on the outside, we're going to have minus 7x. And this does the job because the sum of minus 5 and minus 7 is indeed negative 12 times x. So I've got the answer. Looks like with these factorings, we have pretty much the same pattern in all of the exercises. So let me try to work out another one like 36. Now for a change, instead of letter X, we have B. But we know it doesn't really matter how you call your unknown, with X or with a B or with just about anything else. I just want to start by writing this as a product of 2 parentheses. So B squared, I break with a product of B multiplied by another B. Everything is positive, so I put my pluses. And then I have to factor 36 by multiplying 6 with another 6, right? And this takes care of it because I need to get a 12 in the middle. So 6b and another 6b will give me that 12 that I really need in here. So it looks like we can also write this same answer with b plus 6 raised to the power of 2 because it's squared, and that's what they actually do in here. So it turns out it's always very nice when you start your trinomial with a perfect square, such as x squared, or we just saw letter b squared. It is nice, but sometimes it doesn't start with perfect square so nicely, like in exercise 37. Here we have a start with a 4y squared. 4 times y squared is here, plus 4 times y, and plus 1 that we need to go ahead and factor with 2 parentheses. So we get a factors of 4y that I can break as 2y multiplied by another 2y. You see, there is no perfect y squared, but 4 was it. Well, I can break this with 2 and 2. And also number 1 factors only one way. It's 1 times 1. And we can check and see that this indeed works because our product on the inside is 2y, and the product on the outside will be also 2y. So when I add these together, 2 and 2, I get 4y, and that's it. That'd be the answer. So it looks like we don't have to always start with just x squared or y squared. We can always have various possible factorings for the first term as well. So let me do one more exercise, number 49. I guess the key part is to get used to this setting, multiplying the inside and then the terms on the outside. So looks like I prepared two parentheses, right? Factor 6y squared, I can try 2y and 3y and see what's gonna happen in here. Then I put pluses, right? And then I'm gonna write this as factoring of 2 at the second terms, and this is 2 times 1. So we're to try and see if this is gonna work or not. So when I try and multiply the inside, producing 6y, and the outside producing 2y, notice that this is not working because when I add 6 and 2, I don't get 7, right? I get 8. So this is definitely no good. So I need to try something else. And turns out people say, how about if you switch? If you put this 1 and 2 in the opposite order, because nobody actually told me here that 2 needs to be in the first parentheses. 2 can be in the second parentheses. So if I try to factor it like that, and I'm going to cross out this possibility because it didn't work, then look what's going to happen. We're getting just what we need. The middle product is 3y, right? And the product of terms on the outside is 4y. So indeed, 3 and 4, which is 7, had been reduced. So the point is that sometimes you don't get what you need right away. So you don't need to panic. You just switch your factors. And in that case, it may work. And I guess the idea is to try to do as many as you can of these exercises so you will get used to procedures. So let me try exercise number 51 here. So I'm gonna, again, try to factor 3-term polynomial expression. So the first term is 6x squared, and then minus 5x and minus 4 next to it. So I'm going to start factoring 6x squared with 3x times 2x, right? So that's, I guess, a good start. And then I need to see how I can possibly factor number -4. So we're going to get 5 in the middle. Well, please notice that one sign must be a plus and the other is minus, right? So there'll be different signs. And then I'm going to need to factor 4. And if I try such a pair of factors as 2 and 2, looks like this is not going to work because we're not going to get 5 in the middle, since the product on the outside is 3 times 2 is -6, and 2 and 2 is 4. So the result is not -5, so that doesn't really work. Well, what should we do? Well, it turns out there is another way to factor number 4. Instead of 2 multiplied by 2, I can try to get it as a 4 multiplied by 1. So I can put a 4, and then in the other parentheses, -1, just like that. Again, see what happens when I multiply these terms on the outside. We get 8x, 4 times 2x, and then -3. So the result is going to be 5, but it's positive, and I need to have negative. So the answer is switch your signs, plus and a minus, and that will take care of it, because during that switch, your 8x will become negative and your 3x will become positive, and you will get exactly -5x in the middle. So it looks like with this type of exercises, you need to tackle it a little bit in order to get the answer. So the message is, when you have first terms that start with not a x squared, but with 6x squared or something, it may take a little longer. But the nicest part is when you start just with x squared by itself. Let's say if you have x squared plus something like 3x, and then -4 to factor. So how about if you try to do this on your own? How about if we have a little quiz for today that says factor this type of expression? So to factor, you just need to put a couple of parentheses, right? Factor the first term and factor the last term, and see what you need to do for factors of x squared and factors of 4. So I'll give you plenty of time to do this, to think about this, and you can, as usual, have a little quiz and let me know what you think the product of this equals to. So that's our little quiz for today. So please try to write this as a product of 2 parentheses. In other words, factor, as usual, put the answer in the Zoom chat. Okay.